All right, so this lesson is over finding the rates of change in linear and quadratic functions, which is something I feel like you've already done. Last class, there are some people that looked like super overwhelmed. So I don't know, maybe it just wasn't a focus in a class you've done before, but average rate of change is the focus in this class. So I'm going to slow down. It's fine. We're doing great on time. I'm not worried. But basically, the average rate of change between any 2 points is the slope of the secant line through those points. Now, I know I told you I graded part of the AP test. I think I told you that. The question I graded was the second FRQ, and pretty much if you mentioned secant line, it almost guaranteed you got the point for that particular question. So I'm going to focus on secant line over and over and over again. You're going to get tired of me saying it, but it's something that is new to you. So if we're looking at this graph right here, this is a quadratic function. This line here is the secant line. Oh, sorry, my Apple Pencil needs to be charged. So the line that is going through the points 0 or -4, 0, and 0, 4, that is the secant line. And the average rate of change on the interval from -4 to 0 is going to be the slope of this secant line. Can you tell what the slope is of that line? It's 1, because you're going up 1, right 1, up 1, right 1. So sometimes if you have a graph, which is not that often, you can just find the slope of the secant line and be done and not go through the whole process. But we're going to practice the process because the majority of the time you have to do it. All right, so basically every time that you're finding the average rate of change of a function, you're finding this on an interval between two x values, you're finding the slope of that secant line. All right, so to find the average rate of change, you basically use the slope formula, the same slope formula that you learned in Algebra 1. You didn't use this notation, because I don't know if you knew function notation yet in Algebra 1. Do you guys remember how you learned it, like what you learned for the slope formula? The rise over the run. Some people say the change in y over the change in x, and then some people just say y minus y over x minus x. Some people say yum-yums on the picnic table. Did any of your Algebra 1 teachers teach you that? Okay, well, we won't talk about it then. To find the average rate of change, you basically are going to subtract the y's in the numerator, that's the rise, and subtract the x's in the denominator. I personally like this notation because that's the same notation we use in calculus. So I'll have you write it, but I will tell you exactly what the AP pre-calculus people are going to look for when they're grading your test. All right, so all we have to do is two things. We need to find the values of the function for a given interval, and then you basically just use that slope formula to find the slope between those 2 points. Now, I would say most of the time, whenever you're doing these problems, you are going to be able to use a calculator, but I cannot promise you all of the time. So I'm going to do it both ways. We're going to do some stuff in our head, and then we'll use the calculator also today. So on example 1, we're going to find the average rate of change of the following functions on the given intervals. So some people aren't super comfortable with interval notation, so I just want to remind you all that these are both x's. That's technically, we are finding the average rate of change from when x is -2 to where x is -1. All right, so what we need to find is what f of -2 equals and what f of -1 equals. So on this formula, or this equation, is this negative being squared? It isn't. So if the negative was being squared, it would be -x in parentheses. So it's not, and that always kind of throws people off. But this is technically negative 2 squared plus 3 times -2. Does this negative get rid of that negative? It does not. All right, so we're doing this more pretending like we can't use a calculator on this at first. So this negative drops down. What is negative 2 squared? 4. And then 3 times negative 2? Negative 6. So because this negative, we have to follow the order of operations, so you square first. So that negative drops. Negative 2 times negative 2 is positive 4, and that negative drops down. All right, what's negative 4 minus 6? Negative 10. All right, so it might have been a while since you did stuff like that in your head. You will definitely be expected to know how to do that. But let me show you a super fast way to do something like that using the calculator. And I know you guys know you can do this in the calculator, but I'm not sure, bless you, I'm not sure if you've done this particular thing. So what we're going to do is we are going to put that function into the calculator. You can grab one if you don't have one. So go ahead and get that typed into a Y1, please. I don't know, you guys know, you can go to the table and find what f of negative 1 is. But sometimes you need to find what f of 1.001 is. And so there is a better way than using the table that you can do. Everybody good? Got that typed in? Okay, so what we're going to do is go back to the home screen, so that second quit. And then we're going to use the y variables, which is something you might not have done very much. So to get to the y variables, you hit alpha and then trace. And it gives you 10 choices. It's because if you hit y equals, there's 10 places for you to put a function for y. So we put ours just now. I put mine in y1, so I'm going to choose y1. And then just like this, in red says f of negative 1, we are going to do y1 of negative 1. So we're just going to put this in parentheses. Pretty much every other time in your calculator, parentheses mean multiplication. But when you do this y1 in parentheses negative 1, it means evaluate the function when x is negative 1. And so you just hit enter, and there it is. All right, and so if we're looking for the average rate of change, what we want to find is f of negative 1 minus f of negative 2 over negative 1 minus negative 2. That's function notation for the slope formula. I love that notation. It's important in calculus that you write that notation. In pre-calculus, though, it's not necessary. You could go straight to what you just found these were. So it was negative 4 minus negative 10. I hate writing minus a negative. Are you guys okay if I just do plus positive 10? Okay. And then same thing here. That is just going to be 1 down there. All right, and then that is going to be 6. Now, the question that I graded, you did have to find the average rate of change. And so what I wrote in blue, you had to write all of that. Actually, probably needed to be this. You would have to write all of that to get credit for this question. You didn't have to show this, and you didn't have to show this. It wasn't wrong if you did. You can always show more. But if you just did everything in the calculator and said the average rate of change was 6, you got nothing. So you had to show where you plug those values in to the formula and then what you got for the answer. And so the free response questions, each part is worth 1 point, except for one of them. But mostly they're worth 1 point, and you either get that point or you don't. And if you did everything in the calculator, you don't get that point, which is kind of sad. Okay, let's look at the next one. Oh wait, hold on. What kind of function was this one? Quadratic. All right, what kind of function is this one on B? Linear. So we're going to find the average rate of change of a linear function. Does anyone already know what it is? Just looking at it? Okay, it's okay. All right, so what we're going to find is h of 4 and h of 1. I don't know why I switched the order. That's okay. This might be easier to do in your head. We can do it in the calculator. It's fine. But if I put in 4, I'm going to multiply it by 2. What am I going to get? 8. And then do 1 minus 8, which is -7. All right. If I plug in 1, I'm going to multiply it by 2. I'm going to get 2. And then 1 minus 2, -1. Okay. So I'm going to write out all the things, but I'll specify exactly what you have to do. Now, I like to do h of 4 minus h of 1 over 4 minus 1. But what you absolutely have to write is -7 plus 1 over 3. Now, I just remembered it's fine if you put 3 there. And you have to write what that equals. What does that equal? -2. So it's -6 divided by 3 is -2. So this is 100% needed to get a credit. All right, so that's finding the average rate of change when it's in algebraic form. We're also going to find the average rate of change when it's a graph. And so we have a graph. This is a quadratic function. And we want to find the average rate of change over the interval from -1 to 2. So what I'm going to do is I'm going to find -1. And then I'm going to go up on the function and then find the point on the function when x is -1. I would be doing this now, but I've got to charge this real quick. All right, so that's going to be here. And then same thing on the other side of the interval is 2. I would do that. And I'm going to go ahead and draw the secant line. Whoa. There we go. All right, so the average rate of change of g over that interval is going to be the slope of this secant line. You may be able to go ahead and tell what that is. But let's just go ahead and go through the process, just practicing it one more time by hand. What we would do is g of 2 minus g of -1 over 2 minus -1. What is g of 2? Three, good. G of -1? Nice. All right, so it looks like we get -3 over 3, or -1. And that slope is definitely -1, down 1, right 1, down 1, right 1. All right, you guys okay? Made it through 2 representations. We got 1 more to go. This is the same table that we used yesterday. It is not quadratic, so unfortunately I I couldn't find a good one I wanted to use that was a quadratic function. That's okay. In real life, not a ton of things are quadratic. Like launching an object is always quadratic, but anyway, I use this one because I liked it. So this table is the life expectancy table for U.S. females born in a given year. We're going to find the average rate of change in life expectancy of females born in 1850 to 2000. So even though there are 5 different data points on this table, these are the only 2 I need. Like, I don't care about anything else on this table but those 2 points. All right, now this is not written as a function, so I'm not going to use function notation. I'll just straight go to the subtracting the life expectancy on the numerator and birth year in the denominator. Does the order matter? Kinda. So which life expectancy do you guys want to start with, the 46 or the 81? 46. Okay, so we would do 46.10 minus 81.83. Now, once you do the numerator, the denominator is set. It matters at this point. Which year should I start with? 1850. Good. Now, more than likely, if you are having to subtract decimals inside a fraction, this would definitely be a calculator question. I don't think they're going to expect you to do this in your head or by hand. But I would do the alpha y equals, get the little fraction guy. All right, for a decimal that ends like this one, I would just go ahead and use the whole decimal. But decimals that keep going, it's always important to be accurate to 3 decimal places. And this one is fine. You could do 3 decimal places if you wanted to. But I would just go ahead and write the whole thing out. And it does tell us to indicate the unit of measure. And this is kind of a weird one to do that because both units are years. And so what I decided for life expectancy, I just decided to call it years of life. Or we'll do years living per year. So what this means is each year between 1850 and 2000, the life expectancy of women went up by 0.2382 years of living per year. All right. So we're going to do the top half of this, and then we're going to take a little break until tomorrow. All right, so yesterday we talked about 2 types of rate of change. The average rate of change, which is what we just finished doing, and the rate of change at a point. And so the question is, can you find the rate of change at a point? But you cannot without calculus. And so we're not going to learn derivatives this year, so it's fine. But we will be able to approximate the rate of change at a point. So we can approximate the rate of change at a point by using the average rate of change over small intervals. So here is a ball situation. So a ball is thrown vertically in the air for a time between 0 and 5 seconds. The height of the ball is modeled by that quadratic function, where h is measured in meters and t is measured in seconds. We're going to find the average rate of change in the ball over the following intervals, and we are going to go ahead and indicate the units of measure. So let's put that equation in the calculator in y1. All right, and I'm going to show you guys how to do a super shortcut. I actually didn't show my other class this today. I'll show them tomorrow, though. So this first rate of change that we're going to find is a very small interval. So it's only a tenth of a second. And then the next one is a hundredth of a second. And then the last two are a thousandth of a second interval. So we're getting closer and closer to what the actual rate of change is at 1 second. So this is what we're going to do. So our function is labeled h. So we're going to do h of 1.1 minus h of 1 over 1.1 minus 1. And as long as we typed that function into y1 in the calculator, we can recreate that purple fraction, but instead of doing h, it's going to be y1. So you guys remember how to get to the y variables? Alpha trace, good. Now that bottom, if you just want to go ahead and do the subtraction in your head, you can type it in, whatever you want to do. All right, so we're going to split up the work. So there's 3 more to do. All right, so I'm going to have these 2 rows find B. The row right in front of me, you guys are on your own. I'm going to have you guys find C. And then the last 2 rows, I'm going to have you find D. So you can just straight use this, just changing what is in the parentheses for whichever your second endpoint of your interval is. Now one thing I didn't do that is important is give the units of measure. And so for this situation, what is this 14.71? What's the unit? Very good. Now that is this. Just again, this is not enough work for the AP test. So it's okay for our notes, but we would need to actually use the numbers on it. All right, and I'm just going to write down the answers on the other one. So those of you that did B, what did you guys get for your average rate of change? Good. All right, what about C?
15.195.
Good. So we should be getting closer and closer to the actual rate of change at that point. And then those of you that did D? All right, so even if you didn't do that problem, jot down what the answer is. Okay, so A through C is on the right side of 1, and then D is on the left side of 1, that interval. And so this question right here, it should be kind of in between these two. So if you were just going to guess at what you think it is, what would you guess?
15.
I would guess 15.2 also. All right, so what questions do you guys have about finding the average rate of change or estimating the rate of change at a point? Okay.